Hi, today I'm going to go through the 2016 PAT paper looking at question 14. So question 14, we're told to assume the moons Io and Europa have circular orbits around Jupiter. We're told the radius of Europa's orbit is 1.6 times that of Io's. And we're asked in what ratios are their periods. And we're asked to give it to two significant figures. So let's give us a quick sketch. So if we just draw Jupiter here, well, we know Io is nearer than Europa. So we'll just call this the radius of Io's orbit. And then we'll put Europa somewhere out here. So that's a larger radius. And we'll call that R sub E. And then we'll similarly call the time periods T sub I and T sub E. Well, we know from Kepler's law, Kepler's third law, that the time period squared of any orbit is proportional to its radius cubed. And then that implies that for any two orbits around the same mass, that T1 squared over T2 squared is equal to R1 cubed over R2 cubed for any two orbiting masses. Okay, so in this case here, we have that T sub I squared over T sub E squared is in fact equal to R sub I cubed over R sub E cubed. Well, we know that R sub E is 1.6 times R sub I. So this is equal to 1 over 1.6 cubed, which implies that T sub I over T sub E is equal to 1.6 to the minus 3 over 2. Okay, so let's rewrite that 1.6 as 16 over 10. So it's 16 over 10 to the minus 3 over 2. Well, the square root of 16 is 4, and then 4 cubed is 64. So that's 64 over, well, 10 cubed is 1,000, and the square root of 1,000 is the square root of 10 times the square root of 100, or simply 10 root 10, and all that to the minus 1. So that's equal to 5 root 10 over 32. We've been asked to do this to two significant figures. So two significant figures. So what we can do is we can approximate the square root of 10 by, we can approximate root 10 by 3.2. And then we get 5 times 3.2 divided by 32. Well, 3.2 divided by 32 is going to give you 5 divided by 10, and that is equal to 0.50 to two significant figures.